Okay. This first equation, let's say this is x plus 4 and x minus 3 and 4x plus 12 equals 0. Okay, it's going to happen if and only if and only if x plus 4 is 0 or x minus 3 is 0 or 4x plus 12 equals 0. Okay, now IFS stands for if and only if. The only way this thing can equal 0 is for x equal to -4, right? Then if x equals -4, it is equal to 0. That's what if and only if tells you. So, and we don't, you would add -4 to both sides of the equation, and you don't really need to do that. You can see that. And clearly this, if x equals 3 and only if x equals 3, right? And then I'm glad that's moving. Somebody raising like that, I'm gonna have to go take them out. I'm not up to it. Okay. Just try to talk them down. Don't want to hurt them. Okay, 4x plus 12 equals 0, right? Now you solve it. Subtract 12 from both sides. You get divide both sides by 4. And you get x equals -3. Okay. So just gonna have to close the door in a minute. It's kind of entertaining. That's all right. I could have walked all the way over there. That was a long hike. Thank you. Okay, so now I can say that this equation, expression equals 0. This equation is solved if and only if x equals -4 or x equals 3 or x equals -3. I've written out the total logic of this thing. Okay. Now, I'll do this one. I want to have a little more room to write things out and just show you a little more about the structure, but there's the rationale. Okay, let's do this one. Let's say we got 5/11 plus 8/14. That equals 5/11 multiplied by 14/14. plus 8/14 multiplied by 11/11. And we did this very first thing practically in the course, but we want to refresh you on it because by sometime next week, we're going to be adding expressions for your numerators of polynomial and your denominators of polynomial. So if you don't understand the logic of this, and a lot of people wrote down an answer without really writing down the intermediate step. Don't write down that intermediate step. You're not reinforcing it, and you're going to need it when these things are polynomials, okay? So make sure you understand the intermediate step. We're multiplying by 14/14 because 14/14 is 1. Multiply by 1, you don't change the value, you just change the way it looks, okay? We really need to understand that. Anyhow, straightforward enough. 5 times 14 is 70/154. Of course, 11 times 14 is 154. Plus 88/154. Okay. And that equals 70 plus 88/154. Now, if you're bypassing these steps, make sure you understand the steps because you're not going to be able to bypass it when you have rational expressions, polynomial over polynomial plus another polynomial over another polynomial, okay? You have to follow these steps or you're not going to get there, okay? So anyhow, this is 158/154. Well, that equals 158 divided by 2 over 154 divided by 2, which is 79/77. Okay. Now, every step here is important. Again, because you need all those steps when you do rational functions. So you really kind of want to make sure you can write these out completely. Okay? Then it'll be pretty easy to do rational expressions. Really should be a lot easier. Okay, well, let's look at this third equation. You got 2x minus 7 times x squared plus x minus 6 equals 0. Now, there are two ways I can do this. I'm going to go ahead and do it both ways. Okay. So I can say that, well, it'd be nice if we had this whole thing factored. We would just have a bunch of linear equations to solve. You can factor x squared plus x minus 6. That's x plus 3 times x minus 2. Okay? And then, of course, we still have our 2x minus 7. So now I left myself room to do this in one line. You get 2x minus 7 equals 0. So this equation breaks into 3 equations, each of which is easy to solve. So, well, I'll write out the steps. And there we have our solution, okay? And I'm not going to go over the details of that. I'm sure everybody. Do that. Well, then it's clear here again, just by looking at it, you can tell that x equals -3 is going to be a solution, and x equals 2 is going to be a solution. Now we could subtract 3 from both sides and get x equals -3, right? add 2 to both sides here, we get x equals 3. So now we're going to say that our solution set in the order in which they're written. They usually go from smallest to largest, would be -3 to 7.5, but it's a set, doesn't matter what order this is in. Just a little easier to read if you have them in numerical order, but it's not a big deal. Okay. Okay, that's one way to solve this equation. Yeah. Hang on. Come on. Your cursor's right over the. Okay, we had a question and I'll come back to it. I haven't lost so many brain cells, I forget. If I do forget, tell me. Okay. Okay, so the other way we could solve this equation. We have 2x minus 7 times x squared plus x minus 6 equals 0. So of course, this is true if and only if 2x minus 7 equals 0 or x squared plus x minus 6 equals 0, right? And this is an equally valid way to solve it. Well, of course, x squared plus x minus 6 equals 0 is something we can factor. So we can solve this by factoring. As before, we're going to get x equals 7/2 here. If we factor here, we get x minus 2 times x plus 3 equals 0. Okay. And then this breaks down to x minus 2 has got to be 0, or x plus 3 has to be 0, so we have this. I've got the IFFs in here just to emphasize the logic. But assuming we understand that or just need a simple way to write it out, I can just write out, get this, or we get this. And then from here, this branches off, we get this, or we get this. So now we got this, we got this, and we got this. It's the same solution set. Now quickly, let's say we got let's say we got this. Go ahead and solve that one for me. Oh man. Thought I was recording, but I wasn't. Well, okay, so we see that this equation can break into 3 equations because this factors. Okay. X squared plus x minus 6 factors into x plus 3 times x minus 2. So then this is 0. We have the solution. This is 0. If this is 0. This and this are really easy to solve. You just do it by sight. This one, we want to go through the steps. We have 2x minus 7 equals 0. We add 7 to both sides. To get 2x equals 7, we divide both sides by 2. We get x equals 7/2. And our solution set is 7/2 negative 3, 2. Now, that might be the second time you've seen that, but before I didn't pick up, or I didn't. So here, this, I don't think recorded. Another way to solve this is to say, either this is zero or this is zero. You got two things, their product is zero. One of them has to be zero. So splits into this equals zero or this equals zero. Okay, then, of course, this can be factored. So this equation splits into these two. Oh, well, this equation can be expressed in terms of the factors and splits into two equations, x minus 2 equals 0, x plus 3 equals 0. Well, at this point, we've got the same three equations that we had up here, don't we? Okay. So the question is, do we factor first or do we factor later? Doesn't make a bit of difference. Now, we can't always factor. And I'll give you a hint, you can't factor this. Okay? Not over rational numbers. So see if you can solve this equation, following the logic of the solution. When I look around at how y'all are approaching this problem, you're skipping steps. Most of you, only one person wrote down the first step that you really kind of want to start with to remind you of what's going on. First step is write this. And you write this. Now you don't have this whole thing to worry about. You got this piece and you got this piece. And that tells you and it shows you what you do in such a way that it reinforces it. And if you see it 6 months from now, you're more likely to remember what to do if you follow this form, okay? So I think it's real important to split the thing. They're all, absolute value equations, it's the same thing, okay? And in pre-calculus, nobody's solving absolute value equations correctly because they're not splitting it into two equations, okay? And it's extremely important to do that. It's the same idea, except different context, okay? This splits into two equations. Any polynomial equation will split into two or more equations, okay? But any polynomial equation, at least three, but we'll get to that later. Okay, there's a bit of an epidemic going on in here, obviously. People are trying to make this into a linear equation. A lot of people are, about half and half, okay? So fortunately, this is easier to deal with than the epidemic that causes us to be walking around with masks. Although I'm not mandated to do that anymore. But, and I'm trying to remember to flip the mask up when I come back there and down when I come up here. Okay, so this one solves. I'll write out the solutions. So the steps. 3x plus 5 minus 5 equals 0 minus 5. So 3x equals -5. So 3x over 3 equals -5 over 3. So x equals, I write this symbol for -5 over 3. Yep, this thing has a mind of its own. It will not stay zoomed in the intended manner. At least it's focused. Okay, so x is -5/2. That's one solution. Plug -5/2 into this equation. This is going to give me 0. This won't, but this will. Okay, and 1, 0 is all we need if we multiply a bunch of numbers. Okay, now we got x squared plus x minus 7 equals 0. What are we going to do about that? Well, we have to identify this is a quadratic equation. You can't use the techniques of solving a linear equation to solve a quadratic equation. There are two things you can do, and make sure you got this straight, okay? I'm gonna give you a minute to write that down after we do this. I'll repeat it, okay? But, you know, write it down in big bold letters and tattoo it on your forehead backwards so you can read it when you look in a mirror. No, don't do that. I say that and somebody will do it and then sue me, right? So don't do that. Okay. I don't think anybody in their right mind would do that. Okay. Yeah, I think you all are in your right mind. You all seem very sane. Okay, well, anyhow, we have x squared plus x minus 7 equals 0. Now, up here, we've got x squared plus x minus 6 equals 0. Well, we could factor that, okay? But we can't factor this. Go ahead and try. Exhaust all possibilities. It's not going to work. You get an irrational result. So you'll never find it unless you use a quadratic formula or completing the square, which is equivalent to the quadratic formula. But that's the thing I said, you don't even want to think about that at this point in this course. Okay, so x squared plus x minus 7 equals 0 is a quadratic equation. Get some more exclamation points in the exclamation points in there, if I could, okay? You might even want to do that. When you encounter a quadratic equation, identify it as a quadratic equation, and then solve it by one of two methods, factoring or completing the quadratic equation. If you want to learn how to complete the square, go ahead, but I'm not going to talk about it here. So you'd have three methods, but the two, factoring or quadratic equation, okay? So I'm not going to write out the quadratic formula, we've used it, okay? And you need to know it. So there it is. -1 plus or minus the square root of 29 over 2, okay? Assuming I did my arithmetic right. It's simple arithmetic, so I probably messed it up. There it is, okay? So it's -1 plus the square root of 29 over 2, or -1 minus the square root of 29 over 2. So your solution set would contain this, this, and this. And you want to write it out like this. Now, if you want to write out approximately what the numbers are, which would be very handy if you're trying to graph this expression, then square root of 29 is about 5.4. Okay. Now you can use your calculator to get the square root of 29 and you can plug this into your calculator. You need a calculator to do that. Okay. But you know, I interpolate, you know, square root of 25 is 5, square root of 36 is 6, right? So square root of 29 being between 25 and 36 is between 5 and 6. And it's closer to 5 than it is to 6, but it's kind of getting close to halfway. So it's probably 5.3 something, but I'm guessing it rounds off to 5.4. And you can do that. But plug it into your calculator, make sure it makes sense. And if it's 5.4, you get 2.2, or you get -3.2. Okay. Okay, Now, the main thing. So I want you to write this down, okay? Two ways to solve a quadratic equation. Accurate, use the quadratic formula. Take a minute and write that down to reinforce it for yourself. Okay, I'm glad that question came up because the question was, I remember doing the quadratic formula. Okay, now you should have done it in prerequisite courses, but that might have been 100 years ago. Okay, and it's easy to forget it if you haven't used it. But it's easy, very, very easy. Okay, so and it kind of reinforces what we're doing, so it's a good time to cover. It turns out it is in this course a month from now. Okay, so I don't know why y'all aren't working a month ahead, but I guess I kind of understand. Okay, so here we have it. First of all, quadratic equation has a form. Ax squared plus bx plus c equals 0. It's got an x squared. And I do not now understand why y'all were trying to get rid of the x because you're used to solving linear equations, but it doesn't work. You can't get rid of that x squared. You can't make this into a linear equation. Okay? So you can't make this. Into a linear equation. So you can't solve it by adding things to one side and the other. Actually, there is some you can do, but that's the thing I said we're not worried about in this course. It does come up very close to the end of this course. I want you to see it. Okay, so that when you see it later and really have to know it, it won't shock you. All right, now we can't make this into a linear equation, but easy. So easy to solve. Here's the formula. Okay. And you just got to know that formula. For right now, I don't even expect you to, I'm not going to require you to remember it. If you need it on a test or something, I'll put it on the test. On the final exam, I'll expect you to know it. Okay. But for the next month, you need it, I'll give it to you. If we're using it in class, you don't remember it, say, hey, what's that thing again? I'll write it up. Okay. Now, I don't want to solve that one because there are too many ones in it. And it'll be a better demonstration if I solve. And I'll even put a number in front of x squared, so we don't have any ones. Solve this. You identify A, B, and C. A is the number in front of x squared. B is the number in front of x, and C is the number that doesn't have a variable. Okay. In front of x, you have A in front of x squared. In front of x squared, you have 3. So here's 3, right? Everybody okay with that? And understand how to identify A, B, and C? So go back, take a look at the video if you need to, or just any video on using the quadratic formula, any information you can find online. It's all over the place. There are probably 10 million videos or explanations of the quadratic formula. Okay. Okay, well, first thing you see is a negative b there, right? And b is -4. Negative b is then negative of -4. So you just write down all the symbols, but replace the numbers. Then you worry about, well, there's two negatives, that's going to be a positive. Don't do that in the first step. Okay, it's real easy to kind of be in a hurry and miss that or mess it up. And usually if you mess up the quadratic formula, it's going to cause you way more pain than if you don't. Okay. Okay. So we're just writing it down. Now we got b squared, right? Well, b is -4. But right now, I don't have b squared. The only thing that's getting squared is the 4, and then we put a negative on it. That would give us -16. If you put it in your calculator that way, that's what you'll get. You don't want that. You want to put parentheses around the -4. Now you're squaring the negative as well as the 4. Then it's plus or minus 4a, which is 3, c, which is -12. And then we divide this by 2 times 3. Now we do the arithmetic, or at least we start the arithmetic. The negative of -4 is 4. -4 squared is 16. And I wrote a plus or minus here because y'all are trying to trick me. You asked about the plus or minus just so I do that. Okay, it's minus, not plus or minus. You got to respect this loss of brain cells you got in front of you here. Okay, got a minus here. And then it's going to be minus 4 times 3 times -12 is -144. And then 2 times 3 is 6. That's -4 plus or minus the square root of 16 plus 144. And that comes out 4 plus or minus the square root of 160 divided by 6. Okay. Now, a couple of things you want to make note of this. Well, first of all, let's go back and see how that formula, which I didn't write down here, but I used it, applies to x squared plus x minus 7. Okay, well, what do you got in front of x squared? Well, there's nothing there, but that's implicitly a 1, right? So a is 1, and there's no number in front of the x, so b is 1, and c is -7, right? So now my negative b would be -1 because b is 1. number in front of x is 1, so we have -1. That's where the -1 came from. Plus or minus is there. And then the square root of 1 squared, because squaring b is 1, minus 4ac. Well, 4a is 1, c is -7. Over then 2a, which is 2 times 1. So we just take the numbers we have in front of x squared and x, and the number we got left over there. Plug them in, and then we do the arithmetic. Now you ask about the plus or minus, means plus or minus. So you have one solution for the plus, that's this one. -1 plus the square root of 29 over 2. And the minus, -1 minus the square root of 29 over 2. Okay. Okay. And then, of course, if you end up with something weird like a square root of, I mean, not weird, but if you don't happen to have a perfect square here, you're probably going to have to use your calculator to approximate it. All right. Now, quickly, I do need to give you a little introduction. 5 minutes or less. To rational expression. If you have an expression like this, you can factor the numerator and factor the denominator. Okay. But x plus 2 divided by x plus 2 is just 1, right? So I'm going to write it like this. Because, of course, in a fraction, you multiply the numerators and you multiply the denominators. If I multiply the numerators, well, clearly I get this. If I multiply these denominators, clearly I get this, right? So this is x plus 3 over x minus 3 times 1, which is just x plus 3 over x minus 3. Okay. In the homework that's due Friday, I think, you're given expressions like this. What you have to do to simplify them is you factor them. And then you see what terms they have in common. You rearrange it, you get some ones, and everything goes down. Okay. Now this depends on being able to factor. Okay. So that can be a little bit of a challenge, but it's as simple as that. Other videos on the first 3 problems, I think, are not bad. The other thing is, rational expressions don't get hard until you start adding them and subtracting them. We're not doing that until next week. The other thing is, if I have like this, what do you think? Multiply the numerators and you multiply the denominators. And that gives you this. Okay? Now, at this point, you try to factor this and try to factor this. I don't think either one of them factors. Then you would then try to factor these two. In the case of the problems that you're going to have in homework, most likely things are going to factor. Okay? I'll give you one more hint. Give me one more minute. If ax squared plus bx plus c factors, then the expression of your quadratic formula is going to give you two integers. Okay? Because the square root of b squared minus 4ac because b squared minus 4ac will be a perfect square. Since you're taking the square root of it, you want it to be a perfect square. If it isn't, it's definitely one factor. Now, this won't factor. If you gotta go ahead. I'll continue with this and you can look at the video. But this won't factor because b squared minus 4ac is 3 squared minus 4 times 1 times -5, which just coincidentally equals 29 that we saw in another example. And that's not a perfect square. Okay. So if you run into a problem, you can use that test to see if it'll factor. At least if it'll factor over a whole number. Okay. And very good. Okay, the camera got a little bit out of focus. I think everything is still legible. Let's just make it clear, okay? So there's what we wrote.